That skill presents sorting and classifying polyhedra. A polyhedron is a three-dimensional shape consisting of a collection of polygons that are joined at their edges. And here's how it can look like. If you look at the shape, it's got different types of polygons on its surface. There are triangles, there are quadrilaterals, there are pentagons, and so on. And the polygons are joined with each other at their edges. A prism is a special type of a polyhedron with two congruent polygon bases that are parallel, and they are connected by parallelograms. When the connecting parallelograms are rectangles, we have a rectangular prism. Prisms are named by the names of their polygon bases. So we could have a square prism, in which the two congruent polygon bases are squares, or a rectangular prism in which the congruent polygon bases are rectangles, or triangular prisms in which the polygon bases are triangles, or a hexagonal prism in which the polygon bases are hexagons, and so on. A pyramid is a polyhedron having a polygon base and triangular faces originating from each edge on the base that meet at a point called the apex. Pyramids are named by the names of their polygon bases. So we could have square pyramids, in which the base is a square, and the triangular faces meet at the apex. This is called the apex of the pyramid. Or a triangular pyramid in which the base is also a triangle, and so on. Prisms and pyramids have faces, edges, and vertices. For a prism, its faces are its two congruent polygon bases, and also the connecting parallelograms. So if you look at this hexagonal prism, this is a face, this hexagon, and so is the one on the other side, the other hexagon, and also the connecting parallelograms or rectangles. Each one of them is a face of the prism. The edges are the straight lines where two faces meet. So this is one edge, this is another one, this is another one, and so is this, and so on. And then the vertices are the corner points on the prism. These are all the vertices on the prism. So we have faces. This is a face. We have edges. This is an edge. And we have vertices, the plural for vertex. This is a vertex. Similarly, a square pyramid has got 5 faces, the 4 triangular faces, and the square base. So that's 5 in all for this particular pyramid. And then you have the edges. This is an edge, so is this, and this, and this, and so on. And then these are the vertices. For polyhedrons, there's a very useful formula called the Euler's formula that tells us that the number of faces plus the number of vertices minus the number of edges on any polyhedron is always equal to 2. Let's verify this formula on a square pyramid. So if you look at the square pyramid, the number of faces is 5, the 4 triangles and the square base. So F is equal to 5. The number of vertices is equal to 1, 2, 3, 4, 5. So V is also 5. And the number of edges is equal to, you have 1, 2, 3, 4, and the 4 edges on the square base. That makes it 8. So if you do F plus V minus E, you get 5 plus 5 minus 8, which is 2. Let's see how the formula works for a rectangular prism. Here comes a rectangular prism. The number of faces is equal to, we have 1, 2, 1 at the front, 1 at the back, 3, 4 at the 2 sides, and 5, 6 at the top and at the bottom. So number of faces is 6. Number of vertices is equal to 1, 2, 3, 4, 5, 6, 7, 8. So V is 8. And finally the number of edges is equal to, we have 4 edges for the top rectangle and another 4 edges for the one on the bottom. That makes it 8. And then we also have these 4 edges, 1, 2, 3, and 4. So the total number of edges is 4 plus 4 plus 4, which is 12. And if you do F plus V minus E, you get 6 plus 8, that's 14, minus 12, which is 2. So the Euler formula works.